In our previous videos, we were looking at algebraic expressions which had indicators of addition and subtraction, and we learned that we can only add and subtract terms if they are like terms. That's a key thing to keep in mind. We can only add and subtract terms if they are like terms. What we want to now start looking at is we want to look at multiplying and dividing terms. And we can multiply and divide terms that are unlike terms. They do not have to be like terms to multiply and divide them. They only have to be like terms when we add and subtract. That's a key thing to put down and remember. Adding and subtracting requires like terms. Multiplying and dividing does not require like terms. And we need to figure out how to multiply, say, 3x squared times 4x squared. How would we perform that multiplication? Well, in order to do that, we need to stop and remember what it means to be an exponent on a base. What's that really telling us? Well, if you think about it, 3x squared, remember the exponent says we have two x's being multiplied. This is kind of what we think. This is really 3 times x times x. And this is really 4 times x times x. This says we have two x's being multiplied. So if we think about what's being multiplied, we can multiply the coefficients. 3 times 4 gives us 12. And then how many x's do we have being multiplied? Well, we have 1, 2, 3, 4. How would we write that with the base x and an exponent? Wouldn't we write that x to the fourth? Doesn't this say, doesn't x to the fourth power say, write the x down 4 times and multiply? So when we're multiplying with exponents, we want to think about what the exponent tells us as to how many x's there are there that are being multiplied. Let's suppose we had this example. And let's analyze it in terms of what the exponent on the base means. Again, this is what we think. This is 4 and then 3 x's. Isn't that what x to the third means? We have 3 x's being multiplied. And here in our think cloud, this is 2 followed by 4 x's being multiplied. So when we think about what's going on there, I have 3 x's here, 4 x's there. That's 7 x's being multiplied. Wouldn't that be written as x to the 7th? Doesn't this mean 7 x's being multiplied? And 4 times 2 is 8. Did you pick up the pattern of what we can do? In the other problem, we had x to the 2nd times x to the 2nd, and the answer was x to the 4th. Here, we have x to the 3rd times x to the 4th, and the answer is x to the 7th. Can you see that a simple way we can perform that multiplication is just to add the exponents? There are 3 x's here being multiplied, 4 more x's here being multiplied. That's a total of 7 x's being multiplied. So it really becomes very easy to perform multiplication of terms when we simply think about the exponents on the variables.